Start the record. Hey, everybody. Good evening. Here we are, a new week of the Joy of Coding here at Portland State. Let's see here. This week is we're going to focus on refactoring, code refactoring. And so then taking code as it is today and looking for opportunities to improve not the behavior of it, not the external qualities of it, but really the internal qualities of it. So making sure that it's easier to understand, easier to work with, and easier to evolve. And uh, I hope this gives you some, exposure to what bad code looks like and how to make it better. And we'll be doing that tonight with a Kata where we're going to take some really smelly code, talk about it, identify some opportunities for improvement, and then make those improvements. So it'll be a Kata called the Gilded Rose. So that's our focus for tonight. We'll also assign Project 3 to be talking about that. And then on Wednesday, it's our second pair programming activity. For anyone who was here last week and did the first one here in the classroom, you have the option of attending remotely, or rather participating remotely, and I'll pair people who are remote together so you can experience pair programming. Completely valid, but not the place I recommend that you start. If you weren't able to make it last week, then please plan on attending in person in the classroom so that you can experience pairing in person. It's just much more visceral. I found that you learn a lot better when you experience it the first time with other people, so you can more easily have a conversation. But we'll also be talking about continuous integration and how you can leverage continuous integration to get fast feedback on your builds. And time permitting, we'll also see some more advanced features of Maven, like building websites and things like that. So, really cool stuff coming up this week. Oh, also on Wednesday, there are a couple things that are due, including the first project, Project One. We have another quiz, and then also the midterm surveys. Hard to believe that we're pretty much well, this is the middle week of the term, or maybe the end of the final week of the first half of the term. So there's not a midterm a quiz or exam in this class. Instead, there's a survey. I want to hear about how it's going from everybody. Please, take a critical look at what you've been doing. Let me know what has been effective and ineffective. And it counts as a quiz grade. So please provide good evidence that you thought critically about the course and your experiences so far. Let's see here. I appreciate a couple people joining. What's on your minds? So with Project One coming up, and the plan of attack was due on Sunday. I went through those. Looks like people have a good approach to the project. What can I tell you though? What's on your minds? What are you thinking about as we begin the third week of class, fourth week of class? Yeah.
So far, it's going good with me. I don't really have any questions or anything now.
Great. Thanks, Sid.
What is going to hurt us? Because we're reusing the code from project to project, is that correct? What potential decisions we make will hurt us for the later projects to
Well,
avoid?
that's a great question, and I'm glad that you're thinking about that here at the outset. Um, as we saw in with Project Two, and you'll see again with Project Three, the there's some changes to the command line. In Project Two, there was another option that was added, and options are optional. And in Project Three, you'll see that the format of the dates and times on the command line changed. They go from being two arguments for a date and time to three arguments for a date and time because now there's an AM PM component to it. And so then I say historically, one of the things that students have told me is that adjusting their command line logic from project to project to make sure the command line parsing logic to make sure it can handle the different command lines. That's something that's caused them more work and more rework than they initially thought. I think I would say that's the biggest thing I encourage you to think about as you're starting. Is like, hey, if you're if your command line parsing logic is assuming that certain arguments appear in certain places on, in the args array. That's not going to serve you very well over the long run. So I guess if there was anything you're going to pay attention to, it would be that. But
I thought there was strict order enforcement in the requirements doc for Project One,
that's
except
what
for the option.
That's right, except for the right. And same thing with Project Two. The required arguments are all the same, but now there's another option with dash text file. And remember, options are optional, so your command line parsing um, has to consider some options appearing and other options not appearing. So I think the most important thing though is that if you have good test coverage, especially with the command line parsing, then you'll be able to change your code and get quick feedback on what parsing still works and what parsing doesn't.
Okay, thanks.
Yeah, no, great questions. Okay, well, excellent. Let's dive into refactoring then. And we can go there. So let's see here. I've got a handout. I will post this in the Zoom chat. I think I did make a post over the weekend about it also. So this is a handout all about code. I said handout. What's a better word for that? Teaching aid? I don't know. All about refactoring. So I hope that you had the opportunity to review the refactoring lecture. They'll come in handy tonight. If you didn't, you can catch up later. Because this is stuff that you'll see not only in class, you'll see me doing, actually, we'll do some refactoring together tonight. Also, next week, I believe there's one of the there's an activity that we go through where we take the out of the box project for project 4, the REST API, and refactor it to be, do a lot of refactoring there. So there are concepts that I think that are important. So I'll talk about a couple of them here, but I do encourage you to look at the lecture for deeper details. So, there's this wonderful problem with successful software. When software is successful, when someone likes it and keeps using it, they want more. And so then it's very important that software be able to evolve as people do more things with it. Sometimes it's that they want additional functionality. Other times they want the same functionality but more of it, right? Putting more data through your system, having more users use it concurrently. And so then, these are the key drivers for evolving code. So if you want to be able to meet the needs of your users in a timely fashion, you need to be able to change your code quickly. And that means that your code must be written in a way that, who's ever working with it, whether it be a human or an AI, that they can understand it quickly, make sense of it, and make targeted changes to it so that you don't end up with a lot of changes that may inadvertently, introduce bugs. So there are a number of impediments to going fast with software and software development, and many of those can be classified as code smells. The idea is that you look at some code and you say, "Ah, that's awkward. It's hard to work with. It's hard to understand." It's like anything. Some of it's in the eye of the beholder, but there have been a very healthy catalog of well-known and well agreed upon code smells that have been developed over the years. Refactoring aims to take code and improve, like I said, its internal quality, improve how the form factor of it, how to make it more approachable, easier to understand, and therefore easier to involve. It really means adding clarity and making sure that intent is expressed in a way that can be easily understood. And practically speaking, a lot of the times refactoring, what it can do is remove code spells. So for instance, you've got duplicate code or you've got overly complicated logic. The idea is that you want to apply a refactoring to it, not to change the behavior. As a matter of fact, that's an anti-goal of refactoring. Refactoring is meant to change only the way the implementation is expressed. It's not meant to change the behavior of it. So this isn't an optimization in terms of like a runtime optimization, making something faster, making something use fewer memory or disk or other I/O resources. It's really about making it easier for the coder, again, whether it's a human or an AI, to understand it. And so then as a result, uh, refactoring is much easier, faster, and safer when you've got robust unit tests. Or robust tests, automated tests. So as you're changing code, you can leverage your automated tests to identify any behavior that has changed. So, we're going to be talking about refactoring tonight. I do, beyond the lecture, I do encourage you to check out this cheat sheet that talks about it's really small. Talks about all sorts of different smells in code and how you can go about refactoring. We'll be using this a little bit later tonight. So, when I put together the refactoring lecture, I was pleased with the results, but I realized that it's kind of like, well, I was going to say reading the phone book. I don't know if that resonates with you anymore. It's kind of dry, honestly, because it really is it's kind of going through the catalog of like, here's all of the refactors. And it's really, I found it difficult to really express and demonstrate the act of refactoring just in static slides. And even if I tried to have more of a screencast where you're watching me code, it's kind of hard to follow. And it really oftentimes to understand these refactorings, it's better to have a conversation. So to reinforce what's there in the lecture, we do this activity in class where we take some really ugly, smelly code and we explore it. We look for opportunities to improve it, and then we implement some refactorings. And actually, with just a couple of people that we have, I think it'll be a really good conversation tonight. So I'm curious to hear what you all think about it. And the kata that we use is a kata from Emily Bache called the Gilded Rose kata. Um, it's basically something that you see, pretty often in professional environments. You start a new job and you get some code and you're like, hey, you need to go implement a new feature, and you start looking at it and you realize that the code is a mess and the system around the way to contribute to it is a mess or a kind of strange or what likely seem like strange restrictions on the code in terms of what can change, what can't, who owns what, things like that. And furthermore, yeah, there might be unit tests, but they're completely useless. And it doesn't, and you're looking at the code, it's hard to reason about, and things like this. That's what I like about this kata. Isn't it? Yes, it's an exaggeration, but it really, it feels like you're working with, code for the first time. So, what we'll do tonight is watch an introductory video that Emily Bache has together, and then we'll look at the code itself. And then what we'll do is explore some of the test scenarios. We'll write some unit tests, and then once we've gotten a better feel for what the code is like, then I'm going to set you loose on the code itself to look for some smelly things. We'll discuss some of the smells that you find, and we'll use that to then drive the refactoring that we'll do. So I've done this exercise for several years now, and I think it's a good way to explore refactoring in a practical sense. You're not refactoring your own code, which you will find yourself doing over the course of the project, but it does give you but it gives you a good introduction to refactoring. So that's what we'll be doing. Anything you'd like to discuss though at the start? Any topics that occur to you? Anything you'd like to discuss? Yeah, Adam, I saw you come off mute.
Start refactoring. I'm really interested to watch how you push clamping tests into the code
Oh, yeah,
to
yeah,
make
yeah.
sure that the behavior doesn't change. I don't think we start necessarily with unit tests because, well, I mean, you have no idea what the spaghetti is doing yet, except
Yeah,
from
yeah, I'll
like
talk
a
about that.
black box testing perspective.
Yeah, exactly. And this we'll talk about shortly because you're right. As we'll see, there are there's no meaningful unit tests for this code. And that makes it very difficult to approach. And so then the first thing that we'll do is not once we understand the problem, we will write some unit tests to explore and then validate what the current code actually does. And well, I won't give away, not to spoil anything, but this is a very common and I think very effective technique for working with code that you're new to. And this allows you to explore the behavior of the code and encode the behavior of the code before you start messing with it. And what this does is then gives you feedback, gives you confidence that the changes that you've made have not changed the behavior of the code. And as a result, then you can go faster and you can try things out and you'll know right away whether or not what you did had an unintended side effect. Excellent. Okay. Well, let's get started. Oh, I'm going to restart. I'm going to reshare the screen with sound enabled. Share sound, optimize for video.
By my estimation,
You guys hear that okay?
Yes, I can hear it.
Yes.
Excellent. Great, great. So yeah, oh yeah, this is an introductory, 6-minute introductory video for the Kata. Come on. Oh boy, I'm really not able to find the. Can I just restart it? I guess not. Well, by her estimation,
thousands of developers have tried the Gilded Rose refactoring kata. It's by far the most popular exercise on my GitHub pages, with over 4,000 forks. And I've got loads of translations in my repo, over 50 programming languages, most of which were contributed by other people. It's also included in the Arctic Code Vault, so it will be preserved for future generations of programmers to puzzle over why such a bad piece of code ever made it in there. Because fundamentally that's what this is, it's bad code. So why is such a strange little piece of code got so much attention? Hi, I'm Emily Bache, software developer and creator of Saman Coaching. In my channel, you can find content for technical coaches and lead developers. If you like what you see, please hit subscribe and like. This is the scenario. You have just been hired by the Gilded Rose establishment, which is a small inn with a prime location, and the previous developer, Leroy, has just moved on to new adventures.
Goodbye.
The goods sold in the inn are somewhat unusual, and the business rules governing their value are a little confusing. Your job is to develop the system further to support a new kind of product, conjured items. It's all a bit magical and fantastic, and it takes a lot of inspiration from the World of Warcraft, which I've never played, but I'm told all the characters come from that game. You don't actually need to know any of that to do the exercise. Basically, it's an information system with Byzantine business rules and a half-complete spec. Exactly what you're probably used to. So the code is not all that long, but just check out that indentation. We have a serious bumpy road going down there. The logic is, to say the least, tangled. And at first glance, it looks pretty difficult to change anything without breaking the code. Many developers have that experience daily with their production code. But the thing with this exercise is it's not real. So you can try stuff out and discover what works and what doesn't work in an arena where it doesn't matter if it all goes horribly wrong. Once you get the hang of a few refactoring techniques, you can actually clean up the code pretty quickly. So you go from, oh, this code is terrible, I can't change anything, to, no problem, I can fix this. Quite a short amount of time from one to the other, and that's why it's so fun. I didn't invent this exercise. It was originally presented by Terry Hughes in 2011 as a challenge to his colleagues. And I heard about it when Bobby Johnson wrote a blog post and put the starting code up on GitHub. I was intrigued. The code looked bad, and I like a challenge. The thing is, the original code was in C#, which at the time wasn't a language I'd done much work in. So I wanted to do it in Java or Python, my preferred languages at the time. And I didn't find it all that difficult to translate most of it. But the starting point was a little awkward to get a unit and test in place for, so I modified it a bit. And I think I simplified it and made it a bit easier to get going with the refactoring. As you know, I'm a big fan of approval testing, so I also took the time to add a suite of tests in my preferred approval testing tool, Text Test. And when I played with the exercise a bit myself, I thought it might be good to use this in a coding dojo, and I was doing one at the time, so I thought, well, okay, I need to set this up in CyberDojo, which is the tool we were using. It's still up and very useful. You should check it out. John Jaggett invented it. There's a link in the show notes. Anyway, to get it set up in there, I needed it to have a unit test and not text test. So I created just this single failing unit test and added it to the starting position. Having that test there, failing, it's like an open invitation to any slightly OCD programming nerd to come in, oh, I've got to fix that. And then you get drawn in. And I think that's part of the reason for the popularity of it. I really recommend having a go at this exercise. You can pick pretty much any programming language that you like, even UML or XSLT. Yeah, really. It turns out you can write really bad procedural style code in any programming language. And I'm constantly surprised by the pull requests that I get with translations. In fact, I'd like to take this opportunity to thank all of the contributors. So many fun and interesting programming languages. And if your favorite is not in there already, you could fix that. Send me a pull request. Before you do any refactoring, make sure you have some good tests. Either begin with the failing unit test that draws you in and write your own suite of unit tests, or you could try and work out how to use the approval tests that are there with text test. Then you can open the code in your best refactoring IDE, get stuck in. Happy coding!
So yep, that is the kata. So just to reiterate, we've got some really smelly code that we're going to look at, and then we're going to make it better by applying refactorings. So now let's look at the code itself. So in the Kata's repository, the same one that we used for our pair programming exercise, if you update the main branch and actually, yeah, how about you pull down the changes so you can walk through them? There is a new project called Gilded Rose, and this has the code and the requirements, all sorts of information there. So the first thing we want to do is look at this markdown file for the project. Oh, let's see here. Oh yeah, I dropped the URL for that in. And so actually, you should have it already. It's the Kata's repository. So it's the same thing that you were doing for pairing last night. So or last time I'm almost certain that you'd have a checkout of that. But just in case you do, I will drop the URL for it. Yeah, it's here in the. Let's see here. Yeah, so here's the Kata's repository. To everyone. Yep. That's where it is, and it's in the Gilded Rose directory here. Yep, that's where the code is. I'm going to look at IntelliJ though, so it's a little bigger and easier to read. So sorry, and then just to put it to emphasize again, get your Kata's Summer 2026 checkout on the main branch. Pull down the latest changes, and so you can do that with a Git menu and say Git pull, or use update project, which is what I like to do, or you can do it from the command line. That'll get the Gilded Rose directory, and inside that directory, there's a markdown file called Gilded Rose requirements. Let me I'll pause there if anybody has anything they want to let me know about what they are or not able to do. Actually, maybe we won't look at I won't look at the raw markdown. I'll look at the rendered markdown here in GitHub. So again, there's like this inn called the Gilded Rose. It sells some items, a odd variety of items, uh, and so then and we've got the soft and the Gilded Rose Inn has the software that manages its inventory. Um, and so the whole idea is that the goods that are sold there, each of them has basically a quality, meaning like how good it is. And they all have a sell-by date. And the behavior of various and different items, different kinds of items, behave differently as they age. There are some items that get more valuable over time, and there are some items that get less valuable. And then, as we'll see, there are certain items that have interesting behaviors as they age. So there is currently a simple an inventory system in place, developed by Leroy, who's now, as Emily said, moved on to new adventures. And you're hired as Leroy's replacement, and so then you need to make sense of this code so you can add a new feature to it. So all of the items there have two properties. One is a sell in, which is the number of days that we have to sell the item. And then the other one is a quality, which denotes how valuable the item is. Both of these are integers, or simple numbers and stuff. And then at the end of every day, the inventory system goes through and updates the quality of each item based on its sell-in date. So it'll decrement the sell-in date and say, oh, another day has gone by. Goes through and updates the quality of each one of those. So that's fundamentally what each item is all about. But there are some more rules. So once the sell-by date is passed, the quality degrades twice as fast, right? You've got milk, and it goes sour faster after the sell-by date. Quality never goes negative. And there are other rules, like if you've got an item for aged debris, it actually gets better as it gets older. Most things decrease in quality. Aged debris gets better until ultimately it hits its sell-by date. The quality of item is never more than 50, so it can't get any better than 50. And there is a legendary item called Sulfurous, and it never decreases in quality. It never has to be sold, so it never reaches its sell-in date, and its quality never goes down. And then there's another kind of item that's like Brie, where it gets better as its sell-by date or sell-in date approaches. That's called a backstage pass. So backstage pass has some interesting rules. It's a backstage pass for a concert. So when there are 10 or fewer days before the concert, the backstage pass will have a quality that increases by 2 as it gets 10 days. And when there are only 5 days left, then each day the quality will increase by 3. But then after the concert, after the sell-in date has gone to 0, then the quality is 0. They're not useful anymore. Backstage patches aren't useful anymore after the sell-in date. And so that's the way that the system behaves today. That's the system that you inherited. And we have now there's a new requirement. You just got in a supplier that gives you conjured items, and they decrease in quality. Sorry, they degrade in quality twice as fast as normal items. So those are some of the rules, many of which haven't implemented. And what we need to do is implement these conjured items. And the rules of the code are the following. There's a method called update quality that we'll take a look at here in a moment, and we can make any changes to that. So we can, that's open for for change. And as long as everything still works correctly, we can do anything we want. But there is a class called item that we're not allowed to change because they're owned by the Goblin in the Corner, who will come and do great harm to you if you try to make any changes to it. So it's a nice little constraint about what we're allowed to do with the code. And oh yeah, by the way, one more rule, right? Nothing like a spec that sort of adds things along the way. An item can never have its quality increase above 50. But Sulfurous, being a legendary item, its quality is 80 and never alters. Okay, nice to know. So those are the rules. What do you think about those? Anything that scratches your head, or anything else that you'd want to discuss about the rules? Anything appear to you right away? Yep, saw a couple of chats come in. Okay, glad this makes sense because I find it super confusing. But that's okay because as we'll see, we can encode all of these in tests. So I don't need to keep it in my head. I can have code do it for me. So those are the requirements. When I first introduced this kata, we spent a whole bunch of time like brainstorming scenarios, but ultimately it didn't end up being terribly helpful. It was more interesting to look at the smelly code, so that's what this is all about. So instead of brainstorming given when then, I've got a whole bunch of code. I got a whole bunch of scenarios that we can then implement with unit tests. Before I talk about the unit test, though, there is an interesting integration test. So in the video, she mentioned, sorry, I'll say one thing. We've got, it comes with one unit test out of the box, which is broken. So again, just like the real world, but it gives us an idea of the code that we're dealing with. Um, uh, Oh, nice. Yeah, yeah, yeah. Adam, I'll be getting to that shortly. So the unit test, really what it does is it creates a new Gilded Rose class from a bunch of items in the in, and then calls the update quality method to basically take it from where it is uh, where it is today to where it'll be tomorrow. And this actually is this test is pretty useless because out of the box, it doesn't pass. It has a dumb assertion. So this doesn't really help here. So instead, what we're going to do is implement some more of our unit tests to really help us understand the details of the code. Now, in that comment, in that post that Adam just made, he said that, oh yeah, he's seen something like this before, and what he did, what the instructor did was make a big sort of end-to-end test that exercised many test cases, and actually, the kata comes out of the box with that. As we learned in the video, Emily Bache likes to use this framework called text tests, which lets you test like the input and output of a main program. Actually, it's a lot like our integration tests. And if we look at let's see here, Gilded Rose, and we look at the main. Where's the main? Oh no, it's not that. What is that called? Is it test text fixture? Yes, yes, yes. So it's this unit test right here. Is that right? Yeah. So this unit test right here, if you run it, it's kind of like a main method in that it goes and creates a bunch of very specific um, items and puts them into a Gilded Rose and then goes through, well, actually, oh, sorry, it is a main method. It's a main method that goes through, sets up some test data, runs it through runs it through a bunch of update quality calls and prints the, and prints the result out to standard output. And as you can see when we ran it with, I guess, 2 days is the days by default. You start with all of these items right here. And so then, for instance, a +5 dexterity vest an age debris. And so here on day 0, it has, those values for its sell-in date and quality. I should format that better, but anyway. And then that's day 0. We've got a bunch of other stuff too. Then on day 1, which is the next day, you'll see that things have decreased. So both the sell-in and the quality have gone down by 1. Same thing with the age debris. And so then you can use this as a main method to test a whole bunch of tests, which is good. So what I did here is I've got an integration test that basically uses the invoke main test case functionality to print out the result of invoking that main method for 30 days and comparing it to a known good value, which is right here in the resources, which is the 30 days of standard output. So what I did here is basically said, great, the code before refactoring, I have a more complex test that that is sort of Adam said, like a black box test, where you're not testing the individual code itself. Instead, you are testing the main method, and you're having it do its thing for a long time. And then what the test does is it does a string comparison to the output of running the main method with the expected value. And the expected value is the contents of this text file. And what this allows us to do then is, well, really run a whole bunch of tests after we make some refactoring. And so then actually this is, and we'll probably see it tonight, this will catch defects in our refactoring that the unit tests don't, because it's very specific things. And so then this is just another way of testing. And again, this is a very common thing to do when you are faced with a big complex program, and okay, how to put in these inputs and get those outputs, but that's like at the far edges of the system. It's not the individual tests and not the individual classes and methods that you would exercise with unit tests. So with a combination of unit tests to look at fine-grained functionality and this integration test to look at coarse-grained functionality, what we'll be able to do is provide ourselves enough of a test safety net, I'll say, to be able to implement refactorings confidently. Let's see here. I don't Adam, to your question about if this type of testing was first proposed in the clean code book, I don't know if it was first proposed there, but I'm pretty sure clean code does cover things like that. Regardless, I would recommend buying the clean code book just to there's lots of good stuff in there, including naming and lots of refactoring, and then also some test techniques and some things about unit testing also. Yeah, that's a highly recommended book. So sure enough, let's see here. I'll just run this test. Yep, good, and it passes. And so we'll be using the unit tests and this integration test to give us feedback on the nature of our refactorings. So let's go back to to all this and look at these given when then scenarios. So these are things that I don't know. I put together. Actually, I think the students helped me brainstorm these a couple years ago, and I decided to keep them in because again, it'll save a bunch of time just by implementing some unit tests. Which I'll go through and I'll implement a couple of these now, just to give you an idea of the of the uh, of the code that we're working with. So I'm just going to copy this back to our code here. We're going to look at the Gilded Rose tests. And again, these are unit tests for the that's good. For the Gilded Rose class. So let's see here. We're going to call this update quality well, and we'll just say regular item because this is nothing special. Decreases quality and sell in by 1. Okay. It calls it foo. I don't know. I don't like that. I'm just going to call it regular item. Or yeah, regular item. So we're going to start out with a regular item that has a sell-in. I think sell-in is the first one. Yes. Sell-in of 10 and a quality of 20. And then we're going to create a new Gilded Rose. Well, that's helpful. We're going to update the quality. Yep, that's helpful. Two. And then we're going to assert that, and we're going to have to import this stuff from that. So assert that items, yeah, it was, yeah. Okay. Items 0. Yeah, I don't really like that. We'll have an opportunity to look this up. Item 0 dot sell in equal to, so this gets decremented. This will equal to 9. And then we'll duplicate that line and say quality equals to 19. So I think that implements the test, and I would set it to pass because, well, this code is already implemented. It does. That's good. And so then I'm going to delete this comment because it's pretty easy there. I'm going to go back and look at the next one. Oh yeah, age debris with a sell-in of 2. So actually the quality goes up. It starts at 0, it goes to 1. So again, I'm going to take a comment and I'm going to call this one test void aged free quality increases at end of day. Oh, question in the chat. Why do you choose to use the assert that and equals instead of a quality operator or some other test flavor? Oh, excellent question. It has to do with, so assert that comes from the Hamcrest API, and I like using that because I think once you get used to it, this is pretty easy to read. You have all of the different matchers like contains string and or has item, all of that. So you get a little bit more fluent of an API. But I think really the big thing is that when it does fail, it provides you a lot more context if you were just to always use like assert true with like something. Because if it fails, then all you get is like, oh, it failed. It doesn't tell you much about how it fails. But when you use Hamcrest, it will tell you things like expected and actual. It'll tell you like with contained string, you say, oh, I expected a string that contained this, but instead I got this other string. So it provides a lot more context. So that's why I like to use it. But as you probably noticed, yes, there's a little bit more typing involved. And it doesn't read as natively as if you use just the equals operator. But I found that that's offset the slightly increased cognitive load to read is offset by the increased information available in failure messages. Okay, let's create ourselves a new item here. I'm just going to make the screen bigger so I can see the previous one. Yeah, I'm going to say items equals age debris with, yeah, not 10 and 20. It's going to be 2 and 0. Gilded rows, it makes that. Update quality, it does that. Assert that sell in equals to 0. No, sell in goes to 1. And then assert that quality goes to 1. Okay, I'm going to run this one now. That passes as I expected. I'm seeing an opportunity to refactor here. Now very shortly we're going to talk about various refactorings, but I'm seeing some duplicate code, like all of this, like, oops, all this like creating an array of items and things like that. And then I really don't like having to refer to this array here. So I'm going to do the following. I'm going to refactor some stuff. And I'm going to use some IntelliJ refactor tools. We've seen a couple of them already. I'm going to go into more detail here in a moment, but just to demonstrate, I'm going to do the following. I'm going to pull this code right here out into a variable. And there's one of the ways I can do that. I can actually, if I hover over it, yeah, I get this pop-up that says extract. I can say extract variable. I'm going to call this item. And now I want to have, Oh, and then I'm going to change this not to item 0, but just to item. Yeah, I like that. So let's refactor that. Let's run that again. Nice. And what I want to do is I want to extract like all of this code, these 4 lines of code, into a method that when I pass in the name, the selling, and the quality, it creates a gilded rows, updates, of that item, and then basically does all of this stuff. Oops, does all of this stuff, um, and returns that item. And so I'm going to create variables for all of these, and you'll see why in a moment. This will be the name of the item. This will be, oops, this will be the, come on, sorry. This will be the selling. This will be, I'm using the keyboard shortcut. As you probably noticed, that'll be the quality. And then I'm going to highlight this code and I'm going to say refactor introduce method. And so what this does is it takes the selected code and it creates a new method with that code. And any variables that that code depends on will be created as parameters. So I extracted that. And so it created this method called get item that takes name and sell-in and quality, and then it has that same code there. So it creates the items array, it adds it to the gilded rows and calls update quality, and then returns the item. I guess I can rename it here. Get item. I'm gonna say update quality of item. What do I want to call this? And naming is always the hardest part here. Do I want to say create item? I say create item. Uh, yeah, no, I'm gonna say update quality of item, or just update quality. That's really what it's doing. Nice. Yeah, it's not null. Um, let's see here. Not null. Thanks for asking the question, Adam. Not null prefix seems like is restricting the state of the return value. Any other uses of this method prefix? This annotation right here. Yes, this is something IntelliJ likes to do. Yeah, it's true that this is always non-null, and that's nice to know in a contract. So it tends to add that a lot. I consider it optional, honestly. And as a matter of fact, I think it'll be okay running it from Maven. We'll find out here shortly. So I extracted this update quality method, and so now it's here, and I'm going to run the test again. Nice, that still works. I want to make a couple of other changes though. I don't really need these variables anymore because I don't use them here in my test. So then what I want to do is I want to get rid of this variable and basically take the value of this variable and just use it here directly. Just pass it into the method call because I don't use it anyplace else. It doesn't need to be a variable. So there is an operation called inline, a refactoring called inline. It says inline variable that basically takes the value of the variable, the thing on the right of the equal sign, and replaces any usages of that variable with the value on the right side. So again, if I say refactor inline variable, it then just puts the regular item value right there. And I can do the same with sell-in and quality. Oops, and it looks like my formatting's messed up. I can change that. There we go. Oh, interesting. It's doing 4 indent. I usually do 2. I guess I probably forgot to configure something. Okay, and so now I've inlined those. I think this code is much easier to read, right? It's just very clear. Oh yeah, there's this update quality. You just take that, and now you can assert those things about it. So if I run that, yay, it still works. Okay. I've got some yellow here. It's probably saying that, yep, the value parameter name is always a regular item. That is true, but it won't be for long. So now I want to do exactly that same thing down here in this code. And I'm just going to kind of start over again, I guess. So I'm just going to say item, and I guess age debris. Well, I can just call it item equals new item age debris 2. Excellent. And now instead of the item 0, I'm just going to have item. And here again, just kind of clean up the code, making less code is almost always cleaner. But I still think it's easy to understand. I'm just going to delete all this stuff because this is exactly what oops, I don't want to make a new item. I want to do update quality. Update quality. I probably should have run the test to see that fail and then said, why is it not working? But good. Now that passes also. So that's a quick little refactoring that we can do just with our tests, right? So we're making our test code easier to implement, but as you can see from our test cases, it's going to be like the same thing over and over and over again, right? So let's make that easier. I'm also going to move this method up. I don't know what the menu item is, but the keyboard shortcut is Control Command up arrow. Oops, I thought it was. No, I guess not. What is it these days? Oh yeah, Shift. No, that's previous method. How do I move that up? Yeah, there you go. I moved it up by, okay, it's Shift Command up. Nice. Okay, so I'm going to run all these tests now just to make sure they all pass. And they do. So I'm going to check this stuff in. Let's see here. Added some unit tests for the Gilded rows. Oops, Gilded rows. So what do you think about what we saw so far? Anything that piqued your interest? Anything you want to explore a little further? Cool. Thanks. Glad you like it, Adam. I'm going to do once more. Yeah, we'll look at the integration tests in a little while once we do more refactoring. So let's do one more. Let's see here. The aged brie quality doesn't go down from 50. Oh, right, 50 is the maximum. Yeah. Oops. I should probably add names to these test cases so that's or the stuff in the document to make it a little easier to read and understand. So void maximum quality of aged brie is 50. So here it's 2 and 50, and then assert that sell-in is not 50, sell-in is 1, and quality is 50. Yeah. I'm going to run it using the keyboard shortcut. Yep. Nice. Okay, so then, oh, let's see here. Question: do you always follow camel case convention? Is that just personal preference? Camel case is standard, is conventional for Java programs. So no underbars. Yeah, you can't use dashes, but yeah, so just the way that's just the convention for Java is to use camel case. Um, and yep, you can always tell Java code that was written by a Python programmer because it has underbars. It's legal syntax. It's just that it looks a little jarring to people that are used to coding in Java. So yes, it is personal preference, but it's also it's considered canonical and standard. So let's see here. There's a whole bunch more of these things to implement, but I think you're getting you're getting the feel of it. So let's move on to the code itself. Oh, okay, yeah, and also okay, yeah. Also, why do I use these big old names for test cases? It's more expressive. I got to admit that I'm always challenged by like especially when it comes to tests, how do you describe the scenario being tested? Right? And so then you can do it in a comment, which is, yep, it's possible. But I've found that if you're going to go to the effort of typing in a comment, can you just make the method name as descriptive as a comment would be? Because otherwise, you're kind of duplicating information. You've got to name the method something. Just calling it test 47, yeah, that's not very helpful, especially in output like this, when you look at the, the reports that are generated from your tests. So I got into the habit of putting the effort into the coming up with a method name that is ultimately descriptive enough that I don't need a comment. And as a matter of fact, that's one of the code smells that you'll learn about is sort of like excessive comments. Um, Oh, yeah, and another question, does JavaDoc automatically generate the HTML with these natural sentence methods? Yes, it does, although you usually don't generate JavaDoc with test code. It can, it would if you ran JavaDoc across it. But it would just represent them, as that big camel case name. It doesn't try to make it more readable by adding spaces in the middle of it, if you're asking something about that. There are test frameworks that will do that. Nothing that we're going to cover here in this course, but in general, you have Java docs for code that you're going to reuse, so APIs and things like that. Your test code, while there are test frameworks and stuff that you might reuse, that's just more like Java code that doesn't necessarily test itself. The tests themselves, you don't really reuse that like in other projects. It's really, meant to be single purpose and focused. That makes sense. Good questions, though. Thanks for asking. Okay. So we've been, learning about this and experimenting with this item class and this Gilded Rose class, and there's an update quality method. Let's start looking at this code. So here, item, and of course you can navigate to the item by saying go to declarations or usage. Goes to declaration here. This is the item class, and as you recall, the rules of the game are you can't change this. So it's got public fields for the name, the selin, and the quality. It's also got this toString method. Very simple, and we can't change it. Oops. Let's also, sorry, Zoom thing popped up. Let's also go find the Gilded Rose class. Here's the Gilded Rose class. Go to declarations and methods. It's got its constructor. It's got a package protected items field that gets set in the constructor, and it's got this update quality method. And this is the code that she was talking about in terms of, yep, crazy indentation. Look at all the if statements. Oh my goodness. There's a lot here. And then that brings us to the next part of the activity, which is to study this super ugly code. So here we are in Gilded Rose, and it's time now for you to take a little bit of time and study this code and look for things that are smelly. So what we're going to do here is we are going to let's do some individual work. Let's give I don't know, let's take 10 minutes um, and look for code smells in this code, things that kind of make your skin crawl, or things that are just immediately confusing, or things that are duplicate, or things that just like make it harder to work with. Um, and then, so please open up the. Why am I not signed in? I signed in before. There we go. Now I'm signed in. Please open up this document, and actually I'll post it again here in the chat. There's the link to it. And call out a couple of things like what do you smell? Call out which lines you of code you smell it at, and then come up with ideas for how to make it nicer. And again, look back at the lecture and also this code smells to refactoring cheat sheet. And think critically about it. Come up with some ideas, and then we'll reconvene, talk about what it is that you saw, and then we'll start refactoring it to make it better. In the meantime, I'll spend time implementing some more unit tests so we have some better test coverage. Is there anything else I can tell people, though, about this next phase of the activity before we have a few minutes to ourselves? Good deal. I'm going to pause the recording, and let's take 10 minutes. We'll reconvene at 7:11 to we'll reconvene at 7:11 to do some refactoring. Okay, excellent. So yeah, it looks like you've brainstormed some good smells here, and also meanwhile, I wrote a bunch more unit tests. So let's talk about let's talk about what you all saw. So I'm glancing at things here. Repeat if statements directing flow of control. I'm curious. So yeah, we wrote some things here, but let's talk about like what are some of your observations about this code? Um, what did you feel as you were reading this code? What stood out?
Well, at least from the if perspective, it's challenging to just look through and acquire what the flow of control is for the program of the repeated nested if statements. And it's switching between different items.
Mm,
And if that was just contained to each item and not mixing parameters between the two, it would be easier to read.
yeah, agreed there. Sid, Yasmin, what are some of your observations about this code?
I thought the Boolean expressions like line 44 and right underneath it 45 were pretty or kind of complex
Yeah,
to
yeah,
read.
yeah. There's a lot there. Cool. Okay. Uh, oh yeah. Yasmin calls out the lack of documentation. Absolutely. Yeah, boy, it's just like impossible to figure all this stuff out. And honestly, yeah, and so you know what, in a way, the unit tests end up forming the documentation. That's another reason why I like to have these, big long names, is because this actually tells you what the behavior is and then codifies that behavior in a test to make sure that it still works that way. Cool. Okay. Um, so let's see here. Degrade call. Yeah. This is good stuff. So yeah, looking at all these code smells, where do you suggest that we start with refactoring? Like, what would be a good place to get started? So, anybody have a suggestion for what they'd like to change first about this code? Oh, I like that. Yeah, start with the easiest. Yeah, what would be the easiest refactoring that we could do in this code? Ooh, adding comments. Yeah, that's a good idea. Um, and actually, I'm glad that you mentioned that, Sid, adding comments. Comments would help, but as would like better names. So I think for me, when I think about refactoring, I'm like, well, where can we add better either variable names or extract methods from, to then talk more about the intent. Um, that actually, I think, gives us the benefit of comments and that there's readable code, but also helps organize things so that it's just less to scroll through. Repeated code with methane, degraded quality, for example, or improve quality, or just a change quality method. Okay. Yeah. And so that would probably be all of this kind of thing. I like that. Um, but you know what? I think before we start changing functionality, I think there's some things about the shape here that that I recommend that we start with. Like for instance. Oh yeah, okay. Hard code names can be split into parameters. Oh yeah, strings with parameters. Yeah. Um I think yeah, so are you talking about the fact that like the string, backspace pass to this thing like repeats a whole bunch of times? Is that what you all meant by that? Yeah. Okay. Yeah, so here it's not so much. You said replace with parameters. I wonder if you meant like a constant instead. And that's what I would suggest. And IntelliJ has a refactoring for that. So Like for instance, what you can do is you can select the code. Well, you can say extract constant, or you can go refactor. Oh, oops, refactor this. Oh, interesting. It's not. Let me try that again. If you select it and then you say refactor, there we go. Introduce constant, it's the same thing. And we'll just call this backstage pass. Backstage, oops. Backstage pass. Nice. And so then this is a constant here, right? It's static final and it's a type string. And notice that it replaced it in all the places that that constant appeared. And actually now so I did a refactoring. I can go back to my test, and I can run it. I can run all my tests again. We'll see that they all pass. I think I also want to use that here too. So doesn't refactor across files, but here I just want to, let's see here. I'm going to say backstage pass, and it'll let me import that constant from Gilded Rose. Nice. And now what I'm going to do is I'm just going to use a text find or search and replace to find all of these instances right here, and I'm just going to replace that with this value, and I'm going to say replace all. And I'm going to rerun my tests again. Good, everything passed. Let's see, your question came in. Do you want to import or keep the constant contained to the file? Great question. I want to import it. Because ultimately, yeah, I think I want to use the constant in the test. We're not really testing string comparison, and I think it just gets sloppy otherwise. And as a matter of fact, ultimately, it's a magic string, and I don't like magic strings. That's a smell in and of itself. I think after we refactor some of this code, we'll see that there might be an opportunity to introduce an object hierarchy for this. Don't know if we're going to get to it tonight, but ultimately, I'd like that backstage pass to like be replaced with like a real, backstage pass objects instead of just like the string constant that we throw around. So we're going to get there, right? Refactoring is very much a evolution. And so then, taking small steps will get us there, especially when we have good tests to provide us feedback with that. But good question. So let's see here. We updated the backstage pass to have this constant. Let's see here. I also want to run my integration test to make sure that when I run that main method, that things still work the same. They have. Not surprising, right? We definitely didn't change behavior here. All we did was change a constant. Um, and now I'm going to go through and do the same for these other constants, just getting rid of them. Going to do that for age debris. Going to do that for sulfurous. I was going to call it sulfurous. Hand of Ragnaros. Yeah. What else do we got? Oh, and that's it. So that makes it easier. Good. I'm going to go back over here, and here's where I'm going to, let's see here. So let's do a search and replace of aged brie. I'll call it aged brie, and it imports it automatically. That's nice. Now I'm going to do another search and replace of aged brie here with aged brie. This is only one of them, but I'll do a replace all. And let's see here. Run all my tests. That looks good. Let's see here. What else did I have? Oh yeah, sulfurous. Great. Let's see, are there any other regular item doesn't need a constant? Conjured items aren't supported yet. Regular item. Good. I think that's it. Oh, and I've got this test here. This is never going to work. I'm just going to delete it. That's much more interesting. Okay. So let's run this test again. Everything passes. Let's run the integration test again. Everything passes. Great. And so now let's commit this up. This is it's almost like, well, it's not red green refactor. It's refactor green, refactor green, refactor green, right? If it's red, oh, then we got to fix something. But yeah, introduce constants. Constants for the names of well-known items. Nice. Okay, good. That to me just seemed like a cheap and easy first cleanup. Um, I'm seeing some yellow, so IntelliJ is telling me some things. What is it saying? For loop can be replaced with an enhanced for. That's a good point. Like one of the other things I find really smelly is that we're always doing this items I thing. It's like, oh my gosh, this code is repeated so many times. So IntelliJ, I'm gonna ask it to fix this. I'm gonna say replace for enhanced for. Oh, it's even telling me it's gonna look like. It's gonna introduce a for loop and it's gonna replace all of those item I with just a variable name items. I like that. Oh, look at that. Oh, and it fixed the indentation too. That's two items here. That's funny because it was four in the other place. But anyway, okay, this is a big change, but it's mainly just structural, right? Yeah, so I don't think we've changed any logic. But you know what? We can find out by running our tests again. Let's run the unit tests. Oops, sorry, I'm gonna close these other tabs. Test fixture. Well, we'll run the integration tests. Yep, still passes. And then we're gonna see item Gilded rows test. We'll run all these. Yay. Okay. Again, nice and easy. And we'll just say use enhanced for loop. And then let's see here, go back to the Gilded rows again. And there's another yellow, which is right here, where it's saying item minus item quality minus item quality can be replaced with 0. Let's do that then. All right, that's just some dumb code right there. And let's rerun our test again. Nice. Okay, and we'll just say fix some dumb code. I That looks like all the low-hanging fruit, which is good, right? That was kind of a nice warm-up for everything. Let's see what else we can do here. Repeated if statements. Oh, interesting. And then looks like you made something. Yeah, do last, do last. Okay, that's cool. Let's see. I think we've done this one. Replace all strings with parameters. Oh yeah, degrade quality method. I like that. Yeah, so let's give that a try. So it would be what? Replacing like this code here with like a degrade quality method. That's cool. Um, or like, yeah. Or yeah, it should be like degrade or decrement quality. Eh, let's see here. Oh, and really it's like this whole thing gets replaced with a method called decrement quality. Yeah, I like that. So I'm going to extract a method from that. I'm going to call it, oh, oops. I see. Okay, yeah, degrading from D and D. Fair enough. Okay, we'll use degrade. Let's see, we can represent a statement or an expression. Oh, okay. Yeah, it's not letting me do that automatically because it's like side effects. This is where I'd love to be able to. This is where I'd love to be able to add a method to the item class, but I can't change the item class. So I wonder if we should introduce a class? Hmm. Hmm. Yeah, I kind of want to go there. Yeah, right. Just do a general class. We could just call it yeah, let's do that. Okay. So, ultimately, you probably sense this too, right? We've got all this logic in here that's sort of based on the type of the item, and it really feels like this is a job for polymorphism, and then we should have classes that override methods to do things. So let's do that and see how it goes. This will be a good thing to do. So now. What we are going to we want a subclass of item that has the ability to uh yeah that has a method that allows us to degrade the quality. So let's go and add that class. So I'm going to go to item. I'm going to open up it over here, and I'm going to add a new class over here. And what do we want to call this thing? Do we want to call it a mutable item? Do we want to call it an inventoried item? Or an item we can change? Any good ideas for what this thing should be called? Oh, I could add the item to the superclass, but that's against the rules of the kata. So I don't know, should we break the rules of the kata or should we just add a subclass? Let's add a subclass just to see what it's like, see how awkward it is. So let's call it mutable item. So it's changeable and this thing extends item. What doesn't it like? Oh, that's a good point. There's not a zero argument constructor because by default, this thing has a zero argument constructor, but there's no inherited zero argument constructor. So we'll have IntelliJ create a constructor matching the super. Nice. Good. So it's got all of that. And now I want to go back and I want to add to my test. I want to create all of these as mutable items. So when I create my item, this thing right here, I want this to be a mutable item now. So those get mutable instances in there. And now in my gilded rows, yeah, okay. I want to say, I want all of these to be mutable items. And it's going to barf because it requires this. So I can't use the for loop anymore, but I can say mutable item. What do I want to do? Okay, how about this? And then this will be, yeah, I'm going to change this to be immutable item. And I'm going to say mutable item. Oops. Mutable item. That's where the indentation got all messed up. There we go. Now the code's a little bit happier. This is awkward, right? But I think this will be intermittent, right? We'll say, okay, we will just, this is the way we can cast it. And so now everything is treated as a mutable item. And now, gosh, I want to run my test again because I've started making changes, but I want to make sure everything still works. Good, it does. Okay. And now I'm going to say the following. Instead of this code right here, I want to say item dot degrade quality. And then I'm going to cut that on the clipboard. And now I'm going to say, oh, excellent question. Let's finish this. I'm going to create the degrade quality method on mutable item. And I'm going to say this dot quality equals this dot quality minus 1. And I'm just going to run my tests again real quick just to make sure they pass. Then we can go through and replace other instances. So a great question came in, like, why do I need to cast here? Well, this is super awkward. Why did I need to do it? The type of the items array is just plain old item. It's the superclass. But yeah, I want to invoke the degrade quality, which only exists on the subclass, on mutable. So when I iterate over items, the type is going to be, oops, that should be mutable item, not immutable. Oh no, it is immutable item, yeah. The type is the compile time type here is items. Remember, there could be other subclasses of items, and maybe there will be in the future. So we have to be explicit then about making the type of item, changing it from what used to be a plain old item, now it's a mutable item, so that I can invoke the method here. Did that make sense? It might not have. I apologize if it didn't. Ah, that's a good point. Yeah. Okay, that's a good point. As long as you make all the additional object children of a mutable item, can't you just change the item list to a mutable items list? Um, yeah. I can, yeah, I think I can do that because I can change this class. Very good. Very, yeah, great idea. Okay, so I'm just going to change this to be mutable item. And now I'll have to go through and change some other things. Let's see here. Change parameter items to mutable item. That's great. Okay, refactor that. And now this thing is, yep, this is removed. So, or this is redundant. And so then I will just change it to this immutable it. And now it's saying local variable item is redundant. That is true. And I think what happens if I remove that here? Inline variable? No, I don't want to do that. I'm just going to delete this and just call it changes back to item. Oh yeah, that's much better. Good call. Oh, it's telling me there are two related problems. What are the related problems? The Gilded Rose test. This thing doesn't compile because, oh yeah, this is a mutable item now. So I'll just change all of these to mutable item. Okay, that looks happier now. What's the yellow here? Oh, I have an unused import statement. That is true. I don't need that anymore. This thing also is unhappy. All right, the main method here. Yep, because all of these are still regular items. So I'll just change them all to mutable. Let's see here. I don't know. Can I just... Yeah, it's hard to read though. Okay. Yeah, I can just change. Oops, I can just change them all here. Nice. Okay. Yeah, I think this is all legal, right? Still within the rules of the game. Okay, it's all green. So now if I run this test, nice. And if I run these tests, there, run those tests. Yep, everybody's all green. Excellent. Okay, cool. So I added that. And now I still need to find other places to degrade quality. So like where else is that? That's Selin. This one is another place for degrade quality. Degrade quality. And those are all increase quality. We'll add that one next. But then again, let's just run our tests. Nice. Okay, this is cool. Introduced a new mutable item class that has a degrade quality method. Yeah, this is looking way nicer. Cool. And let's see here. Okay. And now want to do the same thing for increase quality that we want to call it. Item dot increase quality. Right, increment quality. Yeah, let's say increase. Create method there, put an immutable item, returns void, and then have this. So, as I hope you're getting an appreciation for, this is how you refactor code. You do small things, and if you've got a nice suite of uh, of unit tests of tests, um, then uh, then you can confidently make these changes, and you know that you haven't broken anything. Let's celebrate. Here's another dot increase quality. Okay, nice. Rerun this. Yay! And then rerun. Oops, not that one. I want the test for it. This one. Yeah, rerun this. Yay, all that works. Okay. Add an increase quality method to apply. Okay. Yeah, I like that. That was a nice suggestion. I missed a comment. I don't know if it's worth it or not, just to have this as a change quality. Oh, it's a change quality method. Oh, good question. So that would basically be, hey, you've got degrade quality, you've got increase quality. Are you saying just like have a change quality method and like pass in +1 or -1? Would that sort of be the suggestion there? Yeah, I don't know. What do others think? Would that make the code easier to read, harder to read? Do we do more things about there's quality of 0. Like yeah, what do we do with quality here? I guess we don't. I think we've caught all of the assignments of quality except for this one. Yeah, we could add like maybe like a zero out quality. I kind of like the readability of this, honestly. I think it's okay, right? And I think that way we don't expose the ability to increment. So actually, in some ways, it really protects the quality by, if the field was private, and ultimately that's what you'd like, is a, private field that has the quality value, so you can only increase it by one or decrease it by one or set it to zero. So I think I'm gonna do that. Yeah. Oh, there you go. Yeah. Right. So right, yeah, now I think what I'm suggesting is like, oh, wait a second. You can start moving more of this logic into the mutable item class. Yes. Um, yeah, do that. Yeah, I agree. Yeah, we can start doing that. Uh yeah. Yeah. Yeah, I think so. Um but where to start? So yeah, like the item quality less than 50, like all this stuff here. Quality cannot go below zero. So we've got a test for it. So then, I mean, like, let's see here. If it's not, so if it's not aged breed, it's not a backstage pass, and then if quality is greater than zero and it's not, oh, that's sulfurous, then we degrade it. Otherwise, if it's less than 50, it increases in quality. Oh, wow, that is so confusing. And what's that one? So sorry, just so I can see it better, I'm gonna put those on the same line. There you go. It's a little bit easier. And can I, let's see here, if it's not aged brie and it's not backstage pass, what if I have IntelliJ say invert condition? Does that make it easier to understand? Oh, interesting. So, right, it basically just flipped things around. And so now we can more easily see yeah, here is the logic for aged brie and backstage pass. I find this easier to read. That way it's not sort of this double negative. It's like, okay, if it's aged brie or it's backstage pass, do that stuff. Otherwise, if the quality is greater than zero and it doesn't equal sulfurous, degrade the quality. And actually can I just combine those two lines? Is this the same thing as an and right here? Well, actually, sorry, I just made that change to make it easier to read. I should probably rerun my tests. Okay, those still seem to work. Let me just try the integration tests. Yay, nice. Okay, so then I think that makes it easier to read now. Quality can above 50, move that into the increment method and compress the ifs. Let's give that a try. Yeah. Move around the code to make it easier to read. And I'm committing this now because I had green tests, so it's like, yep, that's good. Okay, so you're saying, hey, listen, move the yeah, quality cannot go above 50, so you can move that into the increment method. Okay. So then here, right, you've got this thing, you got that code, and you kind of got that code. Oh, okay, sure. Yeah, I see what you want to do. So great, increase quality. We want to have this thing then have what we want to say the following. It's like if quality, no, is yeah, less than quality is less than 50, then do the increment. Yeah, you're saying this? Yeah, okay, so let's run the test again. Yeah, let's run the test again, see if that works. Okay, it does. Now let's go and change the Gilded rows so we don't need this if item less than 50 anymore. Oops. Okay. So yeah, let's get rid of this. And where else we call it increase quality? And then here. Okay, yeah. Let's see how this works. Nice. Okay, so now let's run the tests again. Oh, good. All that passes. Let's run the IT again. Nice. Okay, yeah, that seemed to be a good change. Nice. Good. Okay, so we'll say move the logic for um, ensuring the quality is never greater than 50 into the increase quality method. Or not increase. Yeah, increase quality method. Okay. Yeah, so you can see we're just kind of playing around with things. This is the nature of refactoring. You want to work in again, work in small steps. Mm. It's really interesting. We've got these two cases of like, oh, if it's not sulfurous, do something different. I wonder if it's time. Yeah, 'cause is a sulfurous the thing that like never changes? Yeah, like sulfurous never changes. Yeah, right. I think, yeah, I agree with you. I think it's time to like make a type of object just for sulfurous. So, and yeah, let's see if we can get all this custom logic out of here for it's saying, oh, if it's not sulfurous, and see if it still works. Okay. So then let's go to mutable item and create a subclass there. And then so we'll create a Java class, we'll call it sulfurous. And yep, this is going to extend, no, not an item, a mutable item. And we're going to create a constructor matching super. Although the name is always going to be sulfurous, whatever the hell thing. So I want to say, so basically this constant ought to live with the sulfurous class. And I think I can say refactor and move. Let's see here, move members. I want to move sulfurous to I do need as a new constant. I don't want a new constant there. I want to move it to sulfurous. Nice. So yeah, notice that now it's referring to it as sulfurous, and probably the same thing over in the this is another reason to use constant, because look what the IDE can do. So now if I go back and look at the test now also refers to sulfurous. That's cool. Um yeah. And okay, so then here, okay, so now I always want this to be sulfurous. And now it's telling me this went gray, and so it's telling me that the name is never used. So I'm going to safely delete name, which means it's going to delete the parameter and everything that calls that parameter, which is probably nothing right now because I don't create this instance anyway. So that was easy to do. Um, and now, oh, why is this underlined? Oh, typo in worlds. Okay, yeah. Okay, now I'm going to run the tests again. I expect these all to pass. Let's find out. Yeah, nothing interesting there. But now I want to start creating some instances of sulfurous. So this is interesting. This is interesting. Yeah, how do I want to do this? So now I want the update quality method. Okay, so like this is something interesting. So now I want to update quality only knows how to create mutable items. It doesn't know how to create a sulfurous. But like oh yeah, okay, here's an idea. So now here's what I want to be able to do. I want to, and this is in the test code, right? This update quality where I pass in all this stuff. I guess really what I want to do is instead of update quality like this, I want to say update quality of a new sulfurous object with, oops, with a selin of 0 and a quality of 80. Now it's saying, hey, you don't have an update quality method like this, but you know what? I want to create one. So what I can do here is I can say create that method. That'd be the quality of a sulfurous. Now, I don't want this down here. I want it up there with my other one. So I'm going to move it up. Oops, I'm going to move it up all the way to the top. All the way past all of these. There we go. Update quality. And now I'm gonna want I want this thing to basically do all of what this does. And I mean, and so basically I want all of this code right here also up there. So I could, so I'm just gonna, I guess, copy all that and say, hey, well, actually, I'm just gonna copy everything. I could say copy all that and then put it up here. And instead of, oh, it doesn't have a number of days. Okay, fine. So I'm gonna have that. And now instead of the this, I'm going to have sulfurous. It's going to return sulfurous, I guess. And now I've got all this duplicate code, right? All this is duplicate code right here. So I don't like all that duplicate code. So I'm going to do the following. Basically, this then becomes duplicate code. So I'm going to now create a new method. I'm going to extract a method just with this, and I'm going to say update quality. Oh, wait a second. Oh yeah, okay. Update quality, and it takes a number of days and an item. I want the item to be first. So I'm going to change the signature. There's another refactoring that you can do. You can say change signature so that the mutable item is first and then the number of days. And so it goes through and it changes all that. That's nice. And now here I can just say update quality of sulfurous for 1 day. Oops, I gotta say return there. It's red and so, because I don't return a value. Yeah. Okay. So you see what I did there? I'm like, oh, I want to have this other, convenience method for updating the quality of some sulfurous. And now I can just call this update quality method, oops, that takes just any mutable item in a number of days and goes through. And I can use that same method right up here where I create the item. Yeah, just like that. And this is right. This is overloading methods. Right? I've got this update quality method that takes a whole variety of different parameters based on what I need, and it ends up just delegating to other versions of itself. Um, and this is actually a very common technique. And a nice thing about object-oriented programming that you can have these overloaded methods, and that way our tests, yeah, it has code reuse when it needs to, but it also has sort of specialization when it needs to. Yeah, oops, let's try running these tests again and see if they'll pass. Oh, they're good, they do. So that was a nice refactoring right there. As you can see, you refactor both the code and the test code, because it's all code and it should all be readable, by folks. Okay, so then, I kind of want to check that in because all the tests are green. Oh, actually, let me go make sure that um, the integration tests are still green. Yeah, good. Everything's all green. So I'm going to say introduce a sulfurous class. And now I can do some additional refactoring, because now all of this, okay, so we want to be able to get rid of all of this, like if the name equals sulfurous. And I think we can do that by special casing sulfurous. So if item instance of sulfurous, then what do we want to do here? Let's see here. What do the tests tell us that we need to do? What was the deal sulfurous? Quality of sulfurous never changes. So the Sell by never change. Sell and never change. The quality never changes. So I guess we just say continue, right? So we've got so far it's like, nope, we don't need it to, it's never going to change. Is that right? Yep, that appeared to be right there. And now if we rerun all these tests, okay, that was right. And so now that we've done that, any code here that talks about sulfurous, this will never be the case. So item, or rather, this will always be the case. Item name will always be not equal or never will be equal to sulfurous. So I think we can just delete this if statement and always degrade the quality. You guys agree? Does that sound right? Geez, Dave. Here we go. So now we can get rid of all of this. So you see how you're sort of like triangulating the code, or maybe I think strangulate is probably another word people would use. So like sulfurous, we never need anymore. Oops, shoot, I deleted something. Yeah, I did. And that's it, right? So sulfurous. Okay, cool. Let's run the test again. That was a big change. So now we're actually changing like well, we're not changing, actually, we're not technically changing the functionality of the code, but we are, making bigger changes to the code as opposed to structural things like, introducing the constants and whatnot. Okay, so that passed. And but then again, and here again, we've got this suite of integration tests and unit tests that tell us whether or not, something broke. Oh, something broke. Uh-oh. And this is where it gets nasty because this is a super hard thing to debug because it's like 30 days worth of stuff. Interesting. Okay, something broke. Good to know. So I wonder what broke. Something related to sulfurous. No, something. Ooh. Ooh. Okay, this is cool. This is cool. So let's figure out what broke it. I'm gonna go selectively starting to undo. Actually, I'm gonna look. Let's see here. I want to keep that, but I want to undo the other changes. Actually, here's what I'm going to do. I'm going to say, let's look at the diff. I'm going to double click on this, look at the diff. I want to keep that one. I'm going to revert the other changes because now I'm just going to be super careful about the changes that I made. Okay, so I believe this will pass, but let's find out. Okay, that passed. So something about one of those changes that I made related to sulfurous broke things. So I'm not gonna check this stuff in yet. Okay, so let's look at the first one. Okay, so this one, so if I delete that one, okay, that breaks it. Interesting. Okay, so because interesting. So, okay, well, how do we go about doing this? So if quality is greater than 0, and if the name doesn't equal sulfurous. Oh, I know. Oh, I know why. Yeah, I know why. Because can you go to the sulfurous object and degrade the quality method? I don't think we're supposed to. Wait, does the quality, no, the quality of sulfurous should never change. I think I know what the problem is. The problem is actually in the test. So you know what we didn't do? We didn't go and look in the text fixture. Aha, we did not change these to be mutable items. So here's what I think we should add some bulletproofing there. Um, I think we should say the following. We should say this, and that we should say if name equals to sulfurous, then throw a legal argument exception, use a sulfurous object or rather instantiate a sulfurous object instead. Instantiate sulfurous instead. Because yeah. Right? Because we shouldn't be creating mutable items for sulfurous anymore. So we should never be able to create one of these. And I think if we try to run it, yep, it'll fail with this saying that, yeah, instantiate sulfurous instead. So we need to go back and we need to change the text fixture here to create a new sulfurous instead. So this is interesting. This is like, when we refactor, you need to make sure to like, look at all your code, but look, we found it really quick because we had tests. And let's see here, any other sulfurous? No. So now let's run it again. Oh, oh, where did we try to create a sulfur? Oh, oops. Um, yeah, that ain't gonna work because I don't like that. Well, hmm, hmm. Yeah, okay, so what happened here is that when I try to create a sulfurous, it invokes its superclass constructor, and what does it do? It says, "Oh, if we're creating sulfurous, throw an exception," which we don't want to do in this case. So I don't know what we want to do. Here's what we're going to do. We're going to say, I'm just going to delete this now because I think we're okay. Okay, that passed, but that still didn't tell us anything. But I think now if we go back to Gilded Rose and we start deleting these things, now I think we're going to see it's going to pass because we're actually creating those objects this time. Yeah, 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 yeah. Okay, so now let's go through, right? So the whole idea here is that we found a bug in our test because we're still creating a mutable object with the name sulfurous and oh, here's another one. Yeah, and this code does not properly doesn't handle a mutable item with the name of sulfurous once I took all those checks out. So now if I rerun it, that's looking good. And now if I go and run the tests again, get rid of that. If I run the Gilded Rose test again, if I run all these, that's looking good too. And so now there's one more thing I want to change. And this string, what is underlined? Why is it underlined? Typo. I want to look at where this actually I want to get rid of these. I want to say remove custom logic for sulfurous from Gilded Rose. Now, this constant, I don't think ought to be used anywhere except for right here. So I'm going to go look for, I'm going to say find usages, and yep, the only place it is used. So I think I can inline that. So I'm going to inline that. I'm going to say inline all usages has one usage, remove the field, refactor. Nice. And there it is. So now I'm going to rerun the tests again. I'm going to rerun the unit tests. That's cool. I'm going to rerun the text fixture integration test, and that still passes. Great. So again, another important refactoring. We needed that constant to exist for a little bit while we sort of massage all the code to then properly encapsulate what you need to know about sulfurous. Great. Remove the string constant or the name of sulfurous. And again, this is a big part of cleaning up code is moving things around, better organizing things, and deleting things as you need them. And what we just went through here is a very common pattern for taking like that nasty, very procedural looking code. This kind of looks like what you see in like old C code and stuff like that, and making it more object oriented. And so then you can imagine. Yeah, you can imagine how you might do something similar for age debris or the backstage pass. Oh, interesting. So let's see here. What I was thinking about doing next is Like if I wanted to implement age debris, that one seems like the one with like slightly less complex. So backstage pass logic is more complex than age debris, I think. Um, how do we do that one next?
You could just continue with the children objects like we did with,
Yeah.
you could eventually simplify this into just calling the degrade quality and increase quality methods in the end, like the direction that you're going.
Yeah. Maybe I should try that next. Cause like, okay. Yeah, let's do that. We got 15 minutes and let's see what we can do in 15 minutes. Oh, wait a second. No, no, no. There's more I wanted to talk about, wasn't there tonight? I want to talk about Project 3. Yeah, I should do that instead. Well, let's see here. Let's talk about what we do. We would create an age debris class, and then we would have to implement the logic for age debris, which would be, let's see here, which would be, it would all be in here, right? Yeah, I guess it would all be in here. Maybe this isn't so bad because this is only if. Oh yeah, actually, this might be pretty easy to implement, right? Because that's only placed. Well, wait a second. What's this down here? Oh, yeah, I guess we need to need to handle the logic in here in this loop. This applies to age debris. This also applies to age debris. And then wait a second. Look at all this. If it's not age debris and if it's not backstage pass. Oh, this is yeah, so here we probably need to have well actually no, if it's not age debris, and then I guess then this would apply to age debris. So I don't
This
know.
could be a good time to take the
Sorry, what?
transition. It could be a good time to transition to the project. Because
Yeah, yeah, yeah.
I
So
also
yeah,
had some
there's more than we can do in
questions
10 minutes. I think
about
everybody's
Java
brain's
docs.
already full, including my own. So yeah, okay. So it gets more complicated, but I think as you can imagine, we can figure out how to extract the logic related to updating the quality of age debris out of this code here and again into an age debris class, which is much like sulfurous. And maybe that's something I'll do on my own later and send you a postcard about it. But yes. So anyway, so that's code refactoring. Um, what I hope that you saw. Actually, no. Instead of telling you what I think you should have seen, what did you see? So let's take 5 minutes, and I want to hear from you all in terms of what you just observed. What was surprising? What was confusing? What was obvious?
Is this open mic night?
Yes, it is. Yes, yeah. Let's get some beat poetry. Yeah.
But no singing required. Um, like the first time I did this, yeah, by the way, your coding style is so similar to Daniel LeBlanc and Chris Gilmore, and they both work in industry. I don't know if you talked to them, but they have like very similar things that they're all trying to explain, which is
Nice.
kind of fun, even
Okay.
though they work at a bunch of different companies. But they always started with clamping with the test. And I
Yeah.
think that was when I first saw this exercise, I think that was the most valuable to me is these wide cast integration tests. Or I guess coming into a new code base, the most challenging to figure out where you can insert it. In here, it seemed pretty simple
Mm.
because it was already well established. But if you're going into an old code base, like you'd have to like play with it a lot, is what I would
Totally.
imagine.
Yeah, no, thanks. Those are great observations. And Yasmin, I saw that you shared a couple of things here in chat. So even without completely removing the nested if statements, the code is much cleaner to look at and understand. Yeah, agreed. The for loop, yeah, as you pointed out, the for loop's cleaner. The constants, I think, yeah, make things easier to read. It's just fewer characters and oops and such. Yeah, and so a little can go a long way. Now, granted, this is a pathological case. But yeah, it sounds like, yeah, you got a good takeaway of just like even, small things can make a big difference. Nice. Totally. Awesome. Okay, cool. Well, anyway, that's refactoring. We're going to see this again in, let's see here. Yeah, on the 22nd, in a couple of, and we're going to see it next week too, when we refactor the REST API. Nice. Okay. Um, yeah. So then project 3. Let's make this bigger. Okay, now I realize that project 1 hasn't even been isn't even due yet, and so you're probably focused on that. And then last week we talked about project 2, where you take your airline and add the ability to persist the airline and its flights to a file. Project 3 continues the evolution by providing a pretty version of the airline that a human can read. So the intent of the text file is that, yeah, the human can read it to see that it changed, but it's not nicely formatted, right? It's meant to be consumed primarily by a machine. When in Project 3, we are you add you're asked to add a pretty printer to the application that will generate a human readable representation of the airline and its flights, and lets you do things like gives you experience with formatting text, and formatting dates especially. So here's here are the requirements for Project 3. You may have noticed that Abstract Flight has get arrival and get departure methods that return something called a Java time local date time. You could ignore that safely for projects 1 and 2, although you didn't have to. So if you wanted to use them, you could, but that was kind of reading ahead. Well, here in project 3, you'll have to use them. So I'm asking you to implement the get arrival and get departure methods for the flight, and so that means that the arrival and departure times for a flight are now represented as local date times. Also, I'd like you to change the implementation of get arrival string, get departure string to return strings that are formatted using something called format style.short. And all of this is explained in the working with dates and text lecture. So some changes to flight. Also, when flights are displayed, they should be sorted, or rather, no, sorry, flights can now sort themselves too. And so there's if you have I ask you to have the flight class implement the comparable interface. And as you'll learn about, comparable enables a class to naturally order itself against another instance of that same class. And so flights then are sorted alphabetically by their first, or are first sorted alphabetically by the code of their source airport. And if you have 2 flights that depart from the same airport, then they should be sorted chronologically by their departure time. If you have 2 flights that depart from the same airport at the same time, those are considered equal in terms of the contract for the compare to method of comparable. And so then there's that. So there's that new capability that you should add to your flight class. And then all of that is used by a class called Pretty Printer. Now, Pretty Printer is another implementation of Airline Dumper, right? So your text dumper from Project 2 implements Airline Dumper, and your Pretty Printer from Project 3 also implements Airline Dumper, because it takes an airline and then dumps it to some destination. In this case, the format of the airline is nicely is textual, but it's the idea that it's human readable. So this is where you can leverage classes like date time formatter to make your dates look nice. And then also there is a helper class called airport names that for a particular airport code will provide the name of the city there. And note that the pretty printer should also include the duration of each flight in minutes. And so the goal here is that you get to work with local date time in a number of respects, both in the formatting and then also for computing the duration of each flight. So those are changes to the code. The way the user interacts with that code is through the main method. as always. And so then there is a new pretty option that takes an argument, which is the file. So that's where the pretty contents of the airline is written to after the flight has been added to the airline. And note that normally this is a file name. However, if the name of the file is just dash, so you say dash pretty dash, then you should write the pretty version of the pre-representation of the airline to standard output instead of a file. So there's a new dash pretty option. Also different is the format of the departure and the arrival time. We're now using 12-hour time with an AM PM indicator. And as a result, and it's noted down here. So so now this is a valid date, and that means that dates and times now take or now are now expressed as three program arguments instead of two. This calls back to what we were saying at the very beginning of class with regards to having to evolve your command line parsing to now handle a three argument date and time instead of a two argument date and time. There's a couple other requirements. The three-letter airport codes on the command line are case insensitive, and that note that the airline should be pre-printed after the new flight has been added. And note that Project 3 retains the text file capabilities from Project 2. So really the order of operations is, hey, if text file is on the command line, then read in the text file to create the airline, add the new flight to the airline, and then optionally print it out. Oh, and then sorry, write the file back, write the airline back to the file, and optionally pretty print it out if dash pretty is provided. Oops, that space not intentionally left blank. Yeah. So again, there's more capabilities here. There's now this pretty printing. And so then, but as always, error handling is important. It's all part of making a usable product. So again, if there's something missing from the command line or there are extra arguments, print a helpful error message. If the formatted date time is correct, as usual. Here's a new requirement. If the flight's arrival time is before its departure time, it is also an error to do that. So, and note that we ignore time zones. We're not gonna, yeah. I did time zones one year and it didn't help anything, just made things more complicated, so I took them out. And also, it's an error if the three-letter code does not correspond to a known airport. So there's some more error checking that you need to do, more test cases, to implement. And as we talked about last time, just say submit.sh project 3 on one of the CS department's Linux machines to submit it. That's everything I've captured in the assignment. Any initial reaction to that? Anything you'd like to discuss or would like me to clarify? Okay.
I guess I had more questions since we have 3 minutes left
Yeah, yeah.
about Java docs.
Sure.
Can you go over what the formatting for Java doc is
Yeah.
above and for an example?
Yep. Yeah, let's see here. I will point you back to when we covered session 2, session 3, session 4, when we cover that. Here you go. How to document your projects has some information, but I'll go through and speak specifically. So yeah, here's more information about Java docs. You were probably looking at this anyway. Right here is just how to learn about the tool, and then there's also the style guide. But yeah, let me go through a quick example.
Yeah, I just want to see an example with the method and how
Yeah.
exactly it formats in the HTML and linking.
Yep. And also I'll go back to the repository that has my airline project, and we'll just take a look at that one. So we'll go back to actually we'll do a push D David Whitlock joy coding summer
And
2026.
this looks like it may have been auto-generated by IntelliJ.
What does?
Above the student, that student documentation.
It was not auto-generated by IntelliJ. It was there. It was created when I created the project. It's in the template
Oh,
source code. Yep. Yeah, this is a actually, yeah, that might be a better example than airline. Yeah, I don't have anything there. So yeah, we'll take a look at student. So yeah, so student has a number of examples of JavaDoc, right? JavaDoc start with star slash slash and end with star slash, and everything inside here is the JavaDoc comment. So I'm going to go to the student project and I'm going to run Maven W and the JavaDoc um, Maven goal. Okay. And so that ran successfully. As you can see, there were some warnings here. Saying, yeah, there's some.
Those
Hmm?
warnings. Um, does that just, are you gonna mark us off for that? Do we have to have that in the
I'm
Java
not,
doc comments
no,
for
I'm not
all
going to
the?
look at the output of warnings. So yeah, right. The fact that there's a warning isn't a problem. If there's actually JavaDoc missing, that's a problem. Do you understand the distinction between the two? So there might be
Yeah,
some things that don't require it. So I'll show you the HTML version of the JavaDoc first, and I'll show you what I'm actually grading because they are different. Um, open is in the target directory, and then sorry, where is it? It's site. Yeah, no, it's Jacoco. Where is it? Reports. API docs, and then open up the index.html. Here's the generated uh, Java doc, and so you see that it's got text like this class represents a student, and student is in fixed width font, and that corresponds exactly to this class represents a student with the code Java doc tag. And similarly, this Java doc for the student constructor with the name, classes, GPA, and gender in the descriptions, all of that is extracted into the Java doc for the student constructor with this particular formatting.
does that mean then like the method details, is this the same? Like, how did you get different headings? Like
How did
method details is is this just auto generated?
Yeah, this is all generated from those Java.comments comments that precede like the program element says. And so if you go down to the says method, it says, all students say this class is too much work. And so then that gets extracted here and put in that.
Okay.
Yep. So then this is the HTML documentation. This isn't what I'm going to grade. What I'm going to grade is the output when you run Maven with -p for profile, the grader profiler, and you run javadoc. This basically generates the Javadoc in a different way, and it outputs text. This is just easier for me to grade. And so, for instance, here's student, and then it has all these, the Javadoc there. The Javadoc is represented there, and here it puts in the Javadoc for the student and has student constructor, and then it has all of the parameters right there. So this is what I'm going to grade, this is what I'm going to look at. And so, for instance, you know, I would take some points off because, oh, here I have a class that isn't documented. I have public methods that are not documented. Um, Stuff that's private doesn't require, actually, I should probably take that out. Yeah. Oh, that's interesting. Lang, not null. Okay. Um, Yep. But like get pronoun, since it's public, yeah, that ought to be documented. So, lose a little bit of points here. I think, what I'm looking for is just evidence that you documented your code and that you learned about Java.comments. Oh, sorry, Adam, that was inaudible. Could you say it again, please?
Oh, I got it.
Cool. Excellent then.
Thanks.
No, thanks for asking for clarification. It's an important thing, and I know I covered it pretty quick last time. Okay. Excellent. Anything else you'd like to discuss tonight? Okay. Well, hey, thanks for joining. Thank you for the interaction. I appreciate it. Um, Hope everybody has a good couple of days. We'll see you again on Wednesday when we will talk about we'll talk about continuous integration, and you'll do your second pair programming activity. See you then.
Yeah.
Bye.